All right, the indefinite integral. Okay, so we've already done some work with the integral, but remember that the integral is just the area underneath the curve, and that it's really just by taking the antiderivative, right? That's all we got to do is take the antiderivative. But we have to account for the fact that, remember, if I took the antiderivative of 0, let's think I just had 0 d to the x. Well, what gave us, when we took the derivative, what gave us a derivative of 0? Well, it was any constant. So the derivative of a constant is 0. So the antiderivative is just of 0 some constant. So we have to account for that every time we take the indefinite integral. Every time we take the indefinite integral, we have to account for the fact that there's some constant that we may not know that was there from the beginning. All right, so let's go to the first problem of first page of problems here. And let's go ahead and do example number 1. So if I'm going to do the antiderivative here, remember it's just the opposite of the power rule. And I'm just going to add 1 to this exponent and then divide by the new exponent. So this is going to become x squared divided by 2. Right now you could think of this as x to the 0. So this becomes 3x to the 1 and divide by 1 and then plus c. So you could just write this as 1/2 x squared plus 3x plus c. And there's the indefinite integral, or the antiderivative. That's all there is to it. One of the things we can do on some problems like this is we can rewrite it. I could think of this as x to the 2/3 instead of the cube root of x squared. I could think of it as x to 2/3. Now it's real easy to use the reverse power rule. So I just add 1 to the exponent, that'd be x to the 5/3, and divide by 5/3. Don't forget the plus c. Now, typically though, I wouldn't divide by a fraction. Instead, I would multiply by the reciprocal. So I would write my answer as 3/5 x to the 5/3 plus c. And there you go. We've just done the antiderivative. All right, on part B here, I want you to just try it on your own. Think about how you could rewrite it so that it gets a little bit easier, and then try and take the antiderivative on your own. Go ahead and pause the video and give that a try. Okay, hopefully you saw that this is really like saying y to the 1/2 power. And since you have the same base, you could just add 2 and 1/2, and that gives you 2.5. So now it's really easy. Take the antiderivative, you just add 1 to the exponent, you get 3.5, and divide by that new exponent. So y to the 3/2 divided by 3.5. Pretty straightforward. All right, on example 3, we have this going on here, and we have this this product going on, and we don't yet have a product rule for integrals. So what I want us to do instead is think about how we might be able to change the way this is written. Can't I distribute this t squared? And if I do that, I would have the integral of 1 times t squared is just t squared plus 3t cubed. I want to keep that in parentheses because that's all being multiplied by the derivative of t. Now, I'm going to take the antiderivative, and I get t cubed over 3 plus this t would become t to the 4th. And so if I divide by 4, I'm going to have a 3/4 here plus c. And there is the antiderivative of that. A lot easier to do than trying to do some product rule. There is a rule for that. We haven't learned it quite yet, but it's this is obviously a much easier way to attack a problem like that. So in this one, I want you to just try and think about how you could rewrite this one so that's a little bit easier to take the antiderivative. Go ahead and try that on your own, and then and pause the video, see if you can work this one all the way out. Okay, so hopefully you saw that you could actually just square this. If you square it, I use the box method, you get 4t to the 4th, add these things together, you get negative 4t squared, and then plus 1. Antiderivative is pretty simple from here, just add 1 to the exponent, divide by the new exponent. Do that all the way through, and you should get this as the antiderivative for example 4a. All right, let's go to the next page. Okay, I'm going to start you off on this one, but again, you want to try and write it so that you don't have a quotient, right? We don't want a quotient. We don't know a quotient rule for antiderivatives yet, so we want it written as though there is no quotient. So what you can do is you can think of this as the integral of x squared over x to the 4th plus 2x over x to the 4th minus 3 over x to the 4th. Let's put that all in parentheses, put dx. Well, let's go ahead and simplify this. I have x squared over x to the fourth. I could think of that actually as x to the negative 2. And the next one I could think of 2 times x to the negative 3. And finally 3 times x to the negative 4. Put that all in parentheses. Dx. All right, now we can see this is a lot easier to take the derivative of than this. So, or antiderivative of, I should say, sorry. And when we do that, we would end up with, if we're adding 1 to the exponent, this is where it gets a little confusing. Remember, we're adding 1 to the exponent now. So this would be negative 1, and then divide by that negative 1. Plus, now this is x to the negative 2, and it's 2x divided by negative 2, minus x to the negative 3, and this is already a 3 here, and we're dividing by negative 3, and then plus some constant. Now we're going to want to clean this up, because this is just, I mean, look at this, it's just kind of nasty. So let's think about, the negative 1 means it's on the bottom, up here means it's on the bottom, and this negative 1 is just kind of like a coefficient, so we could really just write this as negative 1 over x plus, here we could definitely cancel out those 2's, and again we would have a negative 1 over x squared. Here we could cancel out both of these negatives so that we get a plus 1 over x cubed and then plus c. So I don't really need this plus here. We've got negative 1 over x minus 1 over x squared plus 1 over x cubed plus c, and that would be the antiderivative of this big nasty thing. So hopefully you're seeing this pattern of trying to simplify out the problem before we take the antiderivative. If we try to take the antiderivative of this, it's far more complicated. So, all right, let's go to example 5. What happens if they change this on us? Well, it's no big deal. As long as we're still doing it with respect to our variable, everything's really the same. One of the things I want to remember here, though, is that we can write this as 7 times the integral of theta cubed d theta. Well, let's go ahead and do this. I'm going to add 1 to my exponent, making this 4, and then I'm going to divide by this, and then I'm going to do plus c. All right, well, that's really all there is to it. So this is 7/4 theta to the 4th power plus c. There's the antiderivative, or the indefinite integral. Part B, very similar to the last one. I'm going to let you guys try this one on your own. Just give it a shot, pause the video, and then check back to see if you did it correctly. All right, one of the first things you want to do here is rewrite it so it's just an exponent, not a quotient. And x to the negative 2 is pretty easy. Add 1 to the exponent, you get negative 1, divide by the new exponent, and then you could simplify that to negative 1 over x plus c. Okay, that's it for these notes. I think it's pretty straightforward. Just remember to put in that plus c when you're doing the indefinite integral. We're going to learn about the definite integral soon, and then you'll see when we don't need that c. But for now, you got to put in that c every single time. Okay, otherwise it's not accurate. All right, see you guys on the next video.